Hey everybody, I'm going to talk today about some of the important key methods that we need to be using, and I'm seeing some folks struggle with some of these. So this isn't exactly review. I will show you that we are going to be reviewing some of the key methods that we've used in chapters 1 through 4, but we're going to be taking a serious look at the important methods in chapters 5 through 8. So first things first, I'm going to show you that we have this personality variables thing. Now I'm going to come back to it because I'm going to go to the course calendar and I'm going to click on the Intro to Python, and I'll pause this while it loads. Now I clicked on Notebook 1, as you can see up here, but it doesn't matter what you click on because my plan all along was to do File, New Notebook, and then I use the Python 3 kernel. File, new notebook, Python 3. Okay, and while you can't see it, there are two hubs open. It still has the Notebook 1 open and it has the new notebook open. So what I'm going to do is I'm going to go back to the first tab that I had open and use the back arrow. Why? Because I would like to be back at the course homepage. Why? Well, I'm going to show you. So if you click on Start here and you see the personality variables. So click on Start here and personality variables, and you come to this page and there are some code blocks. I've separated them with these horizontal lines, and there are code blocks, and here is a link to the personality variables data set that we collected here at the University of North Georgia from your peer college students. Okay, so I'm going to leave this tab open on the personality variables, and I have this tab open for a new notebook. And so the first thing I'm going to do, right, is we have initialization code. So I'm going to take it and I'm going to copy, and then I'm going to paste and Shift Enter. Okay, so now my new notebook has the proper initialization code. I'm going to pause for just a second on this. I'll use this. So again, I'm copying and jumping back over and pasting, and I'm executing this. Okay, and then we'll go back and get this. Will load the data table that we need. Again, I'm copying and pasting and hitting Shift Enter, and that doesn't really show anything. So let's do pers.show 5. And so you can see that we have a ton of variables here. Your age, year in school, sex, male or female. This is biological sex. The G21 is your age greater than or equal to 21 years old. So anybody who says no is not yet 21. They're 20 years old or younger. Whether or not you're in the Corps of Cadets, whether or not you're a resident. Now you'll notice that there are three options here on resident. So one is campus resident, lives on campus. Two is lives in Dahlonega near campus. And then three is what we would think of more as a commuter, someone who lives outside the community and drives to school every day. We have Greek, which is whether or not you're involved in a social Greek fraternity or sorority, varsity athlete, which should be clear what that means. Honor society, so this is the involved, yes or no, in an academic honor society. Self-reported GPA, we have sleep. This is an average per day based on the most recent 2 days. The question to the students was, how much sleep have you gotten, including naps, in the last 48 hours? And we divided by 2 to get a 1-day average, or to estimate their 1-day average. Caffeine, this is the number of 8-ounce servings of caffeine that they've had in the last 24 hours. Sit class, do they like to sit in the front, in the middle, or in the back of class? Accept date is a hilarious variable that I will talk to you about when we bring it up. Friends, this is the question, who do you find it most comfortable to make friends with? And you'll notice that, well, you can't see any S's, but OE and S are the categories that we can respond. and it's make friends most easily with the opposite sex. S is for same sex, and E is for equal, no difference. Someone who doesn't really feel like there's a particular biological sex they find it easier to make friends with. We have toxic relationship beliefs, which is better described, in my opinion, as naive relationship beliefs. Stress 1 was in the second week of the semester, and stress 2 was taken again at midterms to see if there would be an increase in stress. CHS is coping humor. Thrill is thrill-seeking. Eating attitudes, type A personality, anxiety, optimism, self-esteem, neuroticism, perfectionism, OCD. These are just OCD indicators. And by the way, anxiety, this is not a true clinical tool. Anxiety is a disorder that in some cases needs immediate treatment. And we don't have a clinical tool here. We have we have a questionnaire that can get at some light, mild anxiety. It is not a diagnostic tool for anxiety. Play is adult playfulness. These are adults who have more childlike, playful qualities, like they still like kicking through piles of leaves and splashing in puddles when it's raining. We have a measure of extroversion, a measure of narcissism. These are 4 different humor styles. There is affiliative and self-enhancing and aggressive. These are sarcasm and put-downs type of humor, and self-defeating, and we have primary humor style. Okay, so sorry, I did want to give you a brief overview of what variables we have to look at. And so let's talk about what it is that's important that we're learning statistically so that we can be prepared for the upcoming content. Okay, so I am going to summarize for you some of these key methods in chapters 3 through 8. That was the plan today. And sorry, I skipped a slide there. There we go. And you guys should be familiar with dot select and dot where and dot sort and dot show. We use these in almost every lesson that we do. Also, dot column. It's important to think of these 2 methods together because dot select gets me a table. Even if I just select one variable, it gives me a 1-column table. Column, on the other hand, works like select, but dot column will get me an array. Okay, so I specify a column and I get that as an array. Why do I need that? Well, some things like sum and average and max and min, they don't work on a table. I need to pull the column out so that I can use it as an array. Dot item and dot take are ways to specify rows or items in an array that we would like to pull out to extract and look at. Okay, so that's pretty much review. What we're going to talk about going forward in chapters 4 through 8, we're going to talk about the different variables that we use for what we call data analysis. And if we have a category variable, we are often using group or pivot, and often a bar graph can be helpful in that instance. And when we're talking about numerical variables, definitely looking at a histogram. When we're looking at 2 numeric variables, we're looking at a scatter plot, and we can do a single box plot or even side-by-side box plots. So returning to our table, let's just see what some of these methods do. So I'm going to use pers.group. Okay, so we said that dot group is for a category variable, so let's do biological sex and let's see what's there. Okay, biological sex dot group, boom. Okay, so what do we get? Well, we find out that there are 74 females and 55 males who answered the survey. Okay, that's good. So we know that there are, a good, almost 20 more females than we have males. Okay, and then there's this, thing that we can do. We can add in the name of another variable, and let's do sleep, and then I can do, say, NP average, and of course I'm sorry. You know what? I'm going to pause this for just a moment. And it's not liking what I'm doing. So I am going to create another table using .select. And I want sex. And let's just go with sleep for the moment. Why? Well, you'll see in just a moment. And let me hashtag this. When I put in the hashtag, it makes it a comment, so the computer ignores it. And wait, this is purse.select, okay, and this is tab equals. Sorry, there's what I wanted. I wanted a table that had sex and sleep. Okay, why? Well, because I wanted to do this to it. I wanted to do the table dot group. It's going to group based on sex, and it's going to have this extra command in here, NP average. What's it going to do? It's going to group based on biological sex, male or female, and it's going to give me the average amount of sleep per night that the males get and that the females get. So let's take a look at that. Okay, so instead of counts, now I have a sleep average, and it appears that the females get about 6.3 hours of sleep per night, and the males get a little bit less, 6.2, I guess, if we rounded that. Not a huge difference, but maybe the males need to consider a way to get a little more sleep at night. We're only talking about, 10 or 12 minutes here, so it's not that big a deal. Actually, we're not talking about that much. A tenth of a point difference would be 6 to 8 minutes, I guess we're talking about. So it's not a huge difference in the average. Males and females are pretty similar in the amount of sleep they get. So this is what we do to help understand a category variable. And we do have this option where we can include NP average, and it will give information about the other variable. Actually, any other. It will do more than one variable. For instance, caffeine. We can see how many servings of caffeine that each group has per day. Why? Because NP average goes across the table and it looks for any numeric variable it has. And notice how very similar. The females drink like 0.02 of a point more. So in terms of number of 8-ounce servings of caffeine, the averages are nearly identical. College students, males or females, regardless of biological sex, seem to drink about the same amount of caffeine. Okay, so let's do this. Let's create another table. And this time I want to use the .select method, and I'll use biological sex, and I'll use the friends variable. Remember, this is the question: who do you make friends with most easily? And I'll do tab.show5. Again, the reason I'm using show5 is because these tables can take up a whole lot of room. So if I do show5, it kind of limits the amount of room vertically that's being taken up just showing the table. But 5 is usually enough to give us an idea of what kind of variables that we have. Okay, and I'll want to do something else. I don't know. We've done sleep and caffeine. We can do, let's do optimism, OPT. This is a measure of how optimistic a person is. Okay, and I'm going to do the same thing that I did before. I'm going to use tab.group, and I want to group based on sex, and I want to do NP average. Why? You'll see. Now notice that, oh wait, I don't have a third column showing up here. So let me go back up and see what the OPT variable looks like. It is lowercase, it's OPT. It didn't like it. I'm gonna, oh, there we go. I didn't hit Shift Enter, and I did not have the table updated to show optimism. And now when I do this, there we go. Now, why is the friends average blank? Well, the friends isn't a number, so it, the middle column there is just O's, Z's, and S's. It can't really take an average. So it can take an average on optimism, and there is a slight tiny difference in the optimism average, but this is where this is an association. This is a relationship we're seeing in the data, but we don't have any evidence that it's a significant relationship. We need to do a scientific test to find that out, and it's called a t-test. The book calls it an A/B test, and we'll be learning about that soon. But I just want to say that right now these averages may look a tiny bit different, but we don't know if there's any meaningful difference in the optimism levels between males and females. We have an observation we can make that it looks to be a small difference where the males are slightly higher, but we don't have any scientific evidence at the moment. Okay, so here's another method we use. This is for two category variables. I can put in the sex and the friends variables, and I want to do a tab show 5 again. Oh, I'm sorry, I don't want to do that. I screwed up. So this is a pivot table. Why? Well, the dot pivot method takes two category variables, and it gives me the counts that fit in each of the groups. And so you can see that 45 females and 37 males said, oh, it doesn't matter what the biological sex of the person is, I make friends equally no difference. 10 females and 8 males said that they found it most easy, or found it easiest for them to make friends with the opposite sex. And the 19 females and 10 males said that they'd prefer making friends with the same sex. So you can see that there are more females, and so these ratios aren't particularly different between the two groups. And again, we could scan for differences, and that's something that we'll learn later in the semester, but this is just a great way to find things out. And we can also throw in the NP average, and I think this is where I'm going to need the collect equals. And I am still getting an error. And what was the other one we had? Sleep. I'm trying to remember. Well, we had optimism. So let's see. There we go. So now we're getting the optimism averages for those who found equally no difference. Here's the opposite sex friends, and here's the same sex friends. There doesn't appear to be a huge difference in these. They're all grouped pretty closely around 20. Some are a little bit lower, some are a little bit higher, but I don't think there's any particular reason we might expect, optimism to be different in these groups. I just wanted to show you that we can use this same idea that we used with group, where we put in an average and we can find the average on a different variable than the two variables that we use to make the pivot table. And these are really good methods for all of our category variables. Can I use .group on a numeric variable? Yes, but it's just a huge long mess. Why? Because every unique number in that list of numbers is its own category. It starts treating it like a category variable, and if you do GPA, For example, and then you do dot group based on GPA, then you get this, and there are 70 rows omitted, so that every single number that you can have becomes its own category and has its own count. And so the dot group method is not a good one for numerical variables. What do we use for numerical variables? Well, histogram is great. Let's try that. And I don't need dot select. I just can tell it, hey, here's a variable, create me a histogram, and boom, it does. So you can see the self-reported GPA of our UNG students. And we can also look at a histogram of the sleep variable. And you can see that it appears that while there are some who get a lot more sleep than the rest of us, and some who get much less sleep than the rest of us, that the tall bars seem to group in here around, 6, 7, and 8, or maybe 6 to 8 hours seems to be what a vast majority, what the middle of the group seems to get in terms of sleep. Okay. I also created the favstats. It's a function, and I created it for you. I'm just going to paste the sleep in there, and I don't want the histogram. I'll just tell you that I need to do dot column. Why am I doing dot column? Well, because this favstats thing needs an array. So if it's going to give me the statistics on the sleep column, I need an array, right? So if I did dot select, this is going to throw an error. Why? Because this favstats does not want a table, and select is going to give me a table. It wants an array, and if I do dot column, it's the same thing. It's, hey, go to the sleep variable and start analyzing. And what do I get? Well, I get the maximum. What's Q3? Q3 is the 75th percentile. And the median, if you think about it, is the 50th percentile. And Q1 is the 25th percentile, right? So 1/4 is 25th percentile, 3/4 is 75th percentile, and we have the minimum. So what the top 5 numbers of the favstats does is it gives us what's called the 5-number summary. And the 5-number summary splits the group into quartiles. So we can see the upper quartile, which is the top 25% of the group, the scores that are in the highest 25%, that are the 25% of scores that are the highest. The lowest quartile obviously is the bottom 25%, and then there's the middle 50%, which is the 2 quartiles in the middle. And then we also got the average and standard deviation, which are important in almost any statistical investigation. So the favstats just went and grabbed us a bunch of good stats, and we can do any of the columns that we'd like to. We can check the Narcissism Statistics and see that this is the MP16, which is a measure of narcissism in the literature that psychologists and psychiatrists have worked on. And we gave it to our students, and you can see what that looks like. And we can also switch, whenever we want, we can do the purse histogram, and we can select narcissism, the narcissism column. And the fun thing about .hist is I don't have to do any select. I just point it at a table and tell it the variable, and it will do it. Okay, and let me pull up the slide here and show. So we showed dot group and dot pivot. I did not do bar H. There have been a lot of bar H examples in the notebooks we did with the textbook. We have done histogram. So what I want to emphasize now is the scatter plot, and I don't think we'll have time to get to the box plot today, but I will be revisiting this So let's definitely take a look at the scatter plot. What does a scatter plot do for us? Well, it compares two variables. So I can compare the sleep variable, dot scatter, and then I can compare sleep to caffeine. Do people who get less sleep need more caffeine? Do people who drink more caffeine get less sleep? I mean, we can take a look at that. And I want to notice a couple of things. First of all, this graph, okay, so what is a statistical graph supposed to do? Well, it's a picture that's supposed to tell a story. I'm supposed to be able to get some narrative out of this. And honestly, it looks like some randomly scattered points. And I say that because I want to show you it has this option where I can throw in a comma and do fit underscore line equals true. Remember, the true needs to be capitalized, so a capital T. Okay, and what happens here, I get the same exact graph, but then it draws in a line. Now you notice that this line is nearly horizontal, so if you end up with a scatter plot that has a fit line that's really has a large slope or a large negative slope, that's more evidence of a connection between the two variables. It doesn't appear that people change their caffeine very much based on how little or how much sleep they've gotten. Although it does appear there is a slightly negative correlation. So let me just go over that, right? So a positive correlation is that they both go up at the same time. You know, as sleep goes up, so does caffeine. That's a positive correlation, right? And then in the opposite direction, if the fit line has negative slope, it means what? It means that as the sleep is going up, the caffeine is going down. So if they go in opposite directions, your line of best fit will be negative. So we do have a slightly negative slope, barely, but this is definitely not really an association. We're really skeptical about this association. And it would be interesting to run this test to see if there is a connection between sleep and caffeine. But we haven't done a statistical test, and I'll say our evidence of association is particularly weak. Okay, so these are the methods that we use to do what's called data analysis. We have some data in our table, and you know, if we want to understand, okay, well, how many, you know, what did the type A variable look like? Okay, well, I can come in here and I can just say type A, boom, and I can look at a histogram where I'm able to see the lower values were down around 22, 21, and the highest values that we had were around 37, 38, but the average seems to be around 30. And so I can also, you know, I can compare type A to another numeric variable by using dot scatter. And we will talk about box plots next time.